When addressing the use of structural reinforcing steel as part of an equipotential bonding grid for a pool surrounding paved area, several factors must be considered. The specific questions revolve around whether a single piece of rebar around the pool's perimeter or a short piece placed under the walkway would satisfy the requirements outlined in Section 680.26 of the relevant electrical code. While the code doesn't explicitly dictate the pattern or length of rebar used, it's crucial to understand the underlying intent and ensure the method employed provides effective bonding. Firstly, consider the use of a single piece of rebar around the pool perimeter. While not explicitly prohibited, this approach is generally not recommended. The primary reasons are conductivity and redundancy. A single piece of rebar may not provide sufficient conductivity to adequately bond the paved walkway to the pool's equipment grounding system. Conductivity is critical for ensuring that all metallic parts within the pool area are at the same electrical potential, minimizing the risk of electric shock. Secondly, corrosion poses a significant threat to rebar, especially in damp environments. Over time, corrosion can degrade the rebar, reducing its conductivity and compromising the effectiveness of the bonding grid. A single piece of rebar offers no redundancy. Should it corrode or become damaged, the entire bonding grid's integrity is jeopardized. Now, let's consider the use of a single 6-inch piece of rebar placed under the 3-foot walkway. This approach is even less likely to meet the intent of the code. Conductivity remains a significant concern. A short piece of rebar simply cannot provide adequate electrical connection across the entire paved area. The purpose of the bonding grid is to create a low impedance path for fault current, ensuring that any voltage differences are minimized. A 6-inch piece of rebar is highly unlikely to achieve this. Secondly, corrosion resistance is still a factor. Even a short piece of rebar is susceptible to corrosion, potentially leading to failure of the bonding connection. Thirdly, the effectiveness of such a short piece in providing meaningful equipotential bonding is questionable at best. It is unlikely to create a sufficiently interconnected grid to ensure that all points on the paved surface are at nearly the same potential. Therefore, best practices suggest installing multiple pieces of rebar at regular intervals. A common recommendation is to use number 4 or number 5 rebar spaced 12 inches on center around the pool perimeter and under the paved walkway. These rebar sections should be bonded together and to the pool equipment grounding system using approved methods. Acceptable bonding methods include exothermic welds and pressure clamps. Exothermic welding creates a permanent, low-resistance connection by fusing the rebar together. Pressure clamps provide a mechanical connection and must be appropriately rated and installed to ensure long-term reliability. When installing rebar, ensure it is properly embedded in the concrete and protected from corrosion. Proper embedment ensures good contact between the rebar and the surrounding concrete, maximizing conductivity. To further enhance corrosion resistance, consider using stainless steel or epoxy-coated rebar. Stainless steel rebar offers superior corrosion resistance compared to standard rebar, but it is also more expensive. Epoxy-coated rebar provides a protective barrier that helps to prevent corrosion. Furthermore, always consult with the local building code and the authority having jurisdiction HA for specific requirements or limitations. Local codes may have additional requirements beyond those specified in the National Electrical Code. The AHJ has the final say in whether an installation meets the code requirements and is safe. In addition, ensure that all bonding connections are accessible for inspection and testing. Periodic inspection and testing can help identify potential problems such as corrosion or loose connections before they compromise the safety of the pool area. Here are some key points to consider when using rebar for an equipotential bonding grid around a pool. Firstly, use multiple pieces of rebar instead of a single piece. Secondly, space the rebar at regular intervals, such as 12 inches on center. Thirdly, bond the rebar together and to the pool equipment grounding system using approved methods. Fourthly, ensure the rebar is properly embedded in the concrete and protected from corrosion. Fifthly, consider using stainless steel or epoxy-coated rebar for improved corrosion resistance. Sixthly, consult with the local building code and the authority having jurisdiction for specific requirements or limitations. Seventhly, ensure all bonding connections are accessible for inspection and testing. Eighthly, maintain detailed records of the bonding grid installation, including the type and size of rebar used, the spacing, and the bonding methods. Ninthly, perform regular inspections of the bonding grid to identify and address any signs of corrosion or damage. Tenthly, test the resistance of the bonding grid periodically to ensure that it remains within acceptable limits. This testing can be performed by a qualified electrician. Let's discuss acceptable materials for the equipotential bonding grid. Copper is an excellent conductor and is often used for bonding and grounding purposes. However, when using copper in direct contact with concrete, precautions must be taken to prevent corrosion. Rebar is commonly used, but it is susceptible to corrosion, so protective measures are necessary. Stainless steel offers superior corrosion resistance, but it is more expensive. Regarding installation techniques, ensure that the rebar is clean and free of rust or other contaminants before installation. Use proper bonding connectors that are listed for direct burial in concrete. Make sure that all connections are mechanically secure and provide a low resistance path. Protect the rebar from physical damage during and after installation. Now, let's consider the importance of proper grounding in conjunction with the equipotential bonding grid. The grounding system provides a path for fault currents to return to the source, tripping a circuit breaker or ground fault circuit interrupter and energizing the circuit. The equipotential bonding grid minimizes voltage differences within the pool area, reducing the risk of electric shock. These two systems work together to provide a comprehensive safety approach. Grounding should be done in accordance with the National Electrical Code, Article 250. Common grounding methods include grounding electrodes such as ground rods or ground plates, and grounding conductors that connect to the electrical service panel. The equipotential bonding grid should be connected to the pool equipment grounding system, which includes the pool pump motor, the pool heater, and any other electrical equipment associated with the pool. This connection ensures that all metallic parts within the pool area are at the same electrical potential. Regular inspections and maintenance of the equipotential bonding grid are essential for ensuring its continued effectiveness. Inspections should include visual checks for corrosion, loose connections, and physical damage. Testing should be performed to verify the resistance of the bonding grid. Any issues identified during inspections or testing should be addressed promptly by a qualified electrician. If the resistance of the bonding grid exceeds acceptable limits, it indicates a potential problem with the connections or the rebar itself. This issue should be investigated and repaired immediately. Over time, connections can loosen or corrode, increasing the resistance of the bonding grid. Regular maintenance can help prevent these problems. When making repairs to the bonding grid, always use approved materials and methods. Ensure that all connections are mechanically secure and provide a low resistance path. Protect the rebar from physical damage during the repair process. It's crucial to understand that the equipotential bonding grid is not a substitute for ground fault circuit interrupter protection. Ground fault circuit interrupters are designed to detect small leakage currents and interrupt the circuit, preventing electric shock. Ground fault circuit interrupters should be installed on all circuits that supply power to the pool equipment and the pool area. Ground fault circuit interrupters are a critical safety device that can save lives. They should be tested regularly to ensure that they are functioning properly. The National Electrical Code provides detailed requirements for the installation of ground fault circuit interrupters in pool areas. These requirements should be followed carefully to ensure that the pool is safe. Ground fault circuit interrupters should be located in readily accessible locations so that they can be tested and reset easily. In summary, the equipotential bonding grid is an essential safety feature for swimming pools. It works by minimizing voltage differences within the pool area, reducing the risk of electric shock. The bonding grid should be installed in accordance with the National Electrical Code and local building codes. Regular inspections and maintenance are essential for ensuring its continued effectiveness. It is not a substitute for ground fault circuit interrupter protection. Ground fault circuit interrupters should be installed on all circuits that supply power to the pool equipment and the pool area. These safety measures help protect swimmers from electric shock. Let's consider specific scenarios and how the bonding grid should be configured. If the pool has a metal fence surrounding it, the fence should be bonded to the equipotential bonding grid. This bonding helps to ensure that the fence is at the same electrical potential as the other metallic parts in the pool area. If the pool has a diving board or slide, the metallic parts of these structures should also be bonded to the equipotential bonding grid. Any metallic objects within reach of a person in the pool should be bonded. For in-ground pools, the equipotential bonding grid should extend at least 3 feet horizontally from the inside wall of the pool. This 3-foot zone is considered the equipotential bonding area. The bonding grid should be installed under the paved walkway or other surfacing surrounding the pool. For above-ground pools, the equipotential bonding grid should extend at least 3 feet horizontally from the outside wall of the pool. The bonding grid should be installed under the surrounding surface. If the above-ground pool has a metal frame, the frame should be bonded to the equipotential bonding grid. When installing the bonding grid, avoid creating sharp bends or loops in the rebar or bonding conductors. Sharp bends can increase the impedance of the bonding path. Use smooth, gradual bends instead. Avoid creating ground loops, which can cause unwanted currents to flow in the bonding system. Ground loops can be created when there are multiple grounding paths for the same circuit. When connecting the bonding conductors to the rebar, use approved bonding connectors that are listed for direct burial in concrete. Ensure that the connectors are properly tightened to provide a secure connection. Protect the connections from corrosion by coating them with a corrosion inhibitor. The size of the bonding conductors should be in accordance with the National Electrical Code. The size of the conductors depends on the size of the circuit that is being bonded. The National Electrical Code provides tables that specify the minimum size of the bonding conductors. When selecting materials for the equipotential bonding grid, consider the environmental conditions. If the pool is located in a corrosive environment such as near saltwater, use corrosion-resistant materials. Stainless steel or epoxy-coated rebar is recommended in corrosive environments. Use bonding connectors that are made of corrosion-resistant materials. Regularly inspect the equipotential bonding grid for signs of corrosion or damage. If any problems are found, repair them immediately. Replace any damaged or corroded rebar or bonding conductors. Retighten any loose connections. Testing the equipotential bonding grid should be performed by a qualified electrician. The electrician will use a low-resistance ohmmeter to measure the resistance of the bonding grid. The resistance should be within acceptable limits. If the resistance is too high, it indicates a problem with the bonding grid. When working on electrical equipment near a pool, always follow safe electrical practices. De-energize the circuit before working on any electrical equipment. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity and it can increase the risk of electric shock. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. Swimming pools can be a source of electrical hazards if they are not properly installed and maintained. By following the safety guidelines outlined in the National Electrical Code and local building codes, you can help to ensure that your pool is safe for swimmers. Regular inspections and maintenance are essential for preventing electrical hazards. The authority having jurisdiction, AHA, has the final say in whether an electrical installation meets the code requirements and is safe. Always consult with the AHA before starting any electrical work. The AHA can provide guidance on the specific requirements for your area. The information provided is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before starting any electrical work. Electrical work can be dangerous, and it should only be performed by qualified individuals. The equipotential bonding grid is just one part of a comprehensive safety plan for swimming pools. Other important safety measures include ground fault circuit interrupter protection, proper grounding, and regular inspections and maintenance. By following all of these safety measures, you can help to ensure that your pool is safe for swimmers. Remember, safety should always be your top priority when it comes to swimming pools. Take the time to learn about the potential hazards and how to prevent them. By following the safety guidelines and consulting with qualified professionals, you can help to create a safe and enjoyable swimming environment for everyone.